Good evening, everyone. It is once again Ted the Speed Learner, and you're watching me at an angle right now because I'm doing a live stream at the moment, and I have said this probably several times before. My laptop is right over here, and I'm now going to continue my review of Danica McKellar's book. That's right, Danica McKellar's book, Math Doesn't Suck. And we're going to go on with this. We're going to discuss organic chocolate, measurement conversions, and child care. Confused yet? You're like, what does any of this have to do with mathematics at all? Or each other, for that matter. In this particular chapter of Math Doesn't Suck, Danica McKellar discusses converting decimal numbers into fractions. Is there an easier way to help children learn this topic? I think there is. I will start by placing platform shoes on my feet and grabbing my polyester suit out of my closet. Does anyone here remember disco line dancing? Or for you country music fans, do you remember country line dancing? In the most basic terms, the concept is the same. You are either dancing to the left or dancing to the right. Get it? That's why they call it line dancing. Okay. In this case, as you take a step to the left or to the right, you're going to add a 0 to a number. Okay, and I'm going to show you exactly how that works. Here's how this one works. Okay, we're going to start with the number, whoops, that's better. We're going to start with the number 100. Then we're going to put 10. Then we're going to put 1. And then we're going to have 1/10, 1/100th, and 1/1000. Take a look at that lovely illustration right there. Okay, why don't you go ahead and copy that, write it down, because I'm going to discuss this here in just a second. If you want to, if you're watching this particular presentation, you can take a screenshot of it, and then you can use it for an illustration, whatever, I don't care. Anyway, the first thing you have to imagine is that 1 is the center of the dance floor. Okay? Think about it for a second. You're on a disco dance floor. The center of it is 1. If you take one step to the left, you will place an extra 0 next to the number 1. That is why this is the center of the dance floor right here. You see that 10 right there? You're adding 1 0 to this, and that's why it's 10. Now, if you take another step to the left, you're going to add another 0 to 10, and that's going to make it 100. Okay? Now, the same concept is true when you go this direction, when you start going to the right. Okay? Now, what really happens here is that when you have this number 1, which is the center of the dance floor, what you really have is a 1/1. Okay? You have a fraction where 1 is the numerator and the denominator. So if we're going to take one step to the right, we're going to add a 0 to this 1, and that becomes 10. So now you have 1/10. Same thing, we take another step to the right, we have 1/100th. And if you take another step to the right, we have 1/1000th. See how that works? Okay. And the reason why this works so well is that this number here is 10 times less than this number. This number here is 10 times less than this number. And this number here is 10 times less than that number. That's how that works. Okay. So when you see the decimal 0.1, let me show you this real quick. If you see the decimal, if you see a decimal 0.1, you have to keep in mind you've already taken one step to the right on the dance floor, because remember, 1 is the center of the dance floor. Okay, so if you take one step to the right, you're going to have 0.1 or because that 0.1 actually represents, let me get rid of this one, 0.1 is equal to 1/10. Okay, so that's why I say, if you see the 0.1, you've already taken one step to the right. Okay, so make sure when you convert it over that you've actually added an extra 0, because you've already taken one step to the right. Now, what if you have the decimal 0.15? Okay, you have the decimal 0.15 right there it is. Alright, what are you going to do? You have to remember you've just taken 2 steps to the right on the dance floor. So, if you're going to convert this over, what you're going to do is you're going to have (15/100). Because what you've done is you've taken 2 steps to the right, so that denominator automatically becomes 100. Now, what about the numerator? Well, the numerator, all you're going to do is remove the decimal point. So we had 0.15, all we're doing is removing the decimal point, and that is the numerator. See how that works? When you removed the decimal point from 0.15, the 15 became the numerator of this math problem. Correct. Now, of course, you can actually reduce this. Okay? And if you do, it becomes 15/100 actually becomes 3/20. 3 is the numerator, 20 is the denominator. 15 is the numerator, 100 is the denominator. Okay. So far, so good. Well, since Danica McKellar actually brought up the subjects of organic chocolate and measuring cups, I decided to go ahead and discuss both in greater detail. So what is organic chocolate? It's grown without the use of fertilizer or chemical pesticides. Once the chocolate is harvested, it's blended with milk. The milk actually comes from cows who are fed a strict organic diet. The chocolate milk mix is not genetically modified in any way. Now, if you want to know more about organic chocolate, go down here in the description of this video and you're going to see a link, and it'll take you right to a web article to tell you more about organic chocolate. But now we have to move on to measuring cups, because she mentioned measuring cups as well. Where did their measurements come from? Well, this involves the British imperial system that was finally established in 1824. They determined that a gallon should represent a volume of 10 pounds avoir du pas of distilled water. What is avoir du pas? Well, let me give you, and it's actually not du pas, it is du pas. Avoir du pas. That's how it's really pronounced. I looked it up. Okay? Now, the first thing I'm going to do is teach you how to pronounce the word avoir du pas. The word avoir, I actually will have a hyperlink down here in this description box that will take you to a video that will help you pronounce the word avoir. It's a French word. Okay? And this particular French word means to have. It's an actual verb, okay? Now, if you combine the word avoir and do, which you should know how to pronounce do, okay, and you think of a puppy's paw, okay, avoir du pas, that's how you pronounce it. Okay. So anyway, now, the etymology of avoir du pas, it comes from the Latin word, Latin has a verb known as habere, which means to have, and Latin also has a word called pensum, which means to weigh. Okay? So, we've learned all this etymology. We've learned how to pronounce a French word. What is distilled water? Well, when you go to the grocery store, you see purified water, you see spring water, you see distilled water, and then you're like, I don't know the difference between any of these things. Okay, well, distilled water works like this. They actually boil regular tap water, and they do it in a special room, and once the liquid changes to a vapor, they cool the vapor, and it comes back down, and it is placed in a bottle. Okay, and what happens during this heating up and cooling down process is that all of the contaminants of tap water sink to the bottom of the container. Okay, the water evaporates and leaves nothing but everything that was actually in the tap water, which is kind of a good thing because you get rid of all those little poisons and stuff, you know. Well, I wouldn't call it poisons, but the contaminants that could potentially make you sick. Not necessarily, but could. But on the other hand, valuable minerals that's in the tap water could also be removed. So there you go. Alright. So, if you're going to drink distilled water on a regular basis, I would highly suggest getting yourself a very healthy diet. Otherwise, there are some minerals that you may not get in your body because you're not drinking tap water. Alright, for information about distilled water, there is a hyperlink down here. You can go ahead and click it, and there you go. So, when we're talking about Edouard Dupas, these measurements, like pint, quart, and even cups, were derived from the measurement of Edouard Dupas. If you want to know more about imperial measurements, you can read this web article. There's a link down there in the description below. Okay, are you ready to finally learn some more mathematics, or do you want me to go ahead and do some etymology and some history lessons? Yeah, well, okay. Anyway, obviously you are. After Danica McKellar discusses ordinary decimal to fraction conversions, she starts a discussion on the topic of child care. Why does she do this? Well, I'm presuming, and I may be erroneous on this, and if I am, I apologize well in advance, but it appears to me like she thinks that young ladies, when they get their first job, it's probably somewhere in some kind of babysitting. I hate to disagree with that, but a lot of times young ladies, their first job is something else like retail or whatever. They don't necessarily just automatically go out and do babysitting to earn money. They can, but that doesn't mean that they probably will. So anyway, if I'm wrong about this, if I'm wrong about my presumption of Danica McKellar, I apologize in advance, so there you go. And then she injects the topic of foreign languages into her child care discussion. Well, why does she do this? Well, if you read her book, the answer becomes clear pretty quickly. But if you continue to watch this video, you might still figure out why she suddenly injects the topic of foreign languages into child care. So, we're going to start our discussion with the number 9. Okay? Why do we do this? Because she discusses the number 9, and she thinks it's some kind of a magic number that can solve converting repeating decimals to fractions. And it kind of can do this, but not necessarily. And I'll show you why I said that. Let's start with a basic number, and this is where she is actually correct. And here we go. Now, I will grant you that 9s are very much involved in repeating decimals when you're trying to convert them into fractions. But that doesn't necessarily mean that 9 is a magic number. And she kind of treats it that way. I'm like, not so fast. Anyway, take a look at that number. 5555. Now, we're going to say, because we're going to put a line across there, that this number just keeps repeating and repeating and repeating and repeating forever. Okay? So, here's what we're going to do. We need a rational number to solve this. Okay? If we're going to turn this decimal into a fraction, we need a rational number to do this. We're going to actually call that rational number x. Okay. Now we have our rational number. We don't know what it is yet, but we have the x. Okay. Now we can start, at this point, setting up an equation. This is a mathematical equation. Anybody that knows this stuff by now should know this. Okay. So we have x equaling 0.5555. Alright, we know right now that this 5555 is a repeating number. We already know that. Okay? Since there are no other numbers in the decimal number, the repeating decimal number obviously is 5, because 5, 5, 5, 5, 5, so on and so on. What should we do next? Alright, I want you to multiply both sides of this equation by the number 10. If you do this, the equation will look like this. Alright, there's your other equation. Now what are we going to do with this? Okay, we're going to form a much bigger equation. And I'm going to show you why in just a minute. Alright, here we go. We have... Alright, here we go. Minus, like this. And then we have... There we go. Alright. There we go. Here we go. So, 10x minus x equals 5 point whatever here. These are repeating. So are these. 5.5555 minus 0.5555. Okay. What happens when we do this? Well, we have 9x equaling 5. 9x now equals 5. What happens after that? Well, you divide both sides of the equation by 9, and your final answer, x is going to equal 5/9, and that's why Danica McKellar considers this a magic number. Now you say, well, wait a minute, why isn't it a magic number? Well, there's a reason for that, and I'm going to get into that right now, because I'm going to show you a different equation and show you why 9 is not as magical as she'd like to have you think it is. Alright? So, let's go down here. Let me give you a number. We're going to start with the number 2.0454545. Just like that. Now keep in mind that the 454545, that's the repeating part of the number. That 0 doesn't repeat anything. Okay, now, what do we do about this? Anyway, what we're going to do is we're going to set up an equation. We're going to take that 2.0454545 and we're going to multiply it by 1,000. So, we're going to have one equation where we got 1,000x equaling 2045.454545. Okay? That's our first equation. Okay? Now, we're also going to have an equation where we have x equaling 2.0454545. We always use the line to say that that's a repeating number. That's what that line actually means. It says, hey, everything underneath this line is a repeating number. Okay. Now the thing is, you could try to solve this right now, but we're not going to do that. We want all the repeating numbers on the opposite side of this equation. So here's what we're going to do. We're going to divide both of these equations, both sides of this equation by 100. Just like that. We're going to divide on both sides by 100. Okay, when we do, we're going to have 10x equaling 20.454545, like this. See that? Okay. Now things become a lot more fun. Alright. Well, did that wrong? Well, that wasn't really all that wrong, but we'll have to multiply this first equation now by 1,000 to make this work. So we're going to multiply the smaller equation by 1,000, and we'll take that decimal point out. Oh, hold on. Hold on. Okay, so we took the smaller equation, we multiplied it by 1,000 on both sides, and now we got, let's take that out. Like that. Okay, so here's what we're going to do. We're going to do 1,000x minus 10x equaling 2045. Ooh, that 5 looks terrible. That's what happens when you're on a live stream. 5.454545 minus 20.454545. Okay? So we have 1,000x minus 10x equaling 2045 point whatever here minus 20.4545 whatever. If we do this, we come up with an equation we finally come up with an equation of 990x equaling 2025. If you divide both sides of the equation by 990, you're going to get a fraction of 2025 divided by 990. Now we can divide both of these by 45, which actually happens to be divisible by 9. So like I said, 9 is not totally magical, but it is somewhat. Okay, so we're going to divide the 2025 by 990. And we'll get an answer of 45 divided by 22. And that's the end of your answer. Okay, so Danica McKellar's math doesn't suck trick with the magic 9s doesn't always work the way that she says it does, but it works to some degree. So it is kind of a magical number, it's just not as magical as she'd like to make it out to be. Okay, so after she discusses repeating decimals, she presents a lesson in astrology. I skipped all that. Why? Because anyone who has watched me on a regular basis would automatically know that I have no interest in astrology. Period. So I won't even get into that. Anyway, in the next lesson, let's see what we got here. Let's see. Let's go over here. In the next lesson, we're going shopping again. I tell you what, if you read this book long enough, you probably would go broke. But anyway, I digress. That's just a little humor. We will be covering some more shopping the next time we do a lesson from Danica McKellar's Math Doesn't Suck book. Anyway, if you can get the book, it'll help you understand why what my critiques are of this particular book. It's not a bad book in particular. It's just yeah, there's some flaws. I can tell you that right now. There are some flaws. But anyway, I digress. That's the end of the lesson for today. I will tell you more in a future video, so I'd like for you to stay tuned.